Hey, if you're watching this, it's probably the first week back to school. Welcome to 310. My name is James, and I'll be taking you on a quick tour of TypeScript, the language you'll use in your project this term. Before we get into what this video is going to be all about, let's quickly go over what it isn't. I'm not going to go over how to write tests for C0, or how to write asynchronous code. These are topics that'll be covered in another TA lecture down the line. I'll try to show you that you already kind of know TypeScript. I'll map over things that you know from Java, like classes, interfaces, and methods, and show them in TypeScript. We'll also explore some common gotchas and how to avoid them, and do some programming exercises. So what is TypeScript? Well, it's a superset of JavaScript. Any valid JavaScript program is valid TypeScript with a star. So in this course, we want you to write type-safe code. So in 310, not all valid JavaScript programs will be admissible by our compiler. TypeScript also has some impressive tooling for object-oriented programming. If you remember your 210, you'll feel right at home. So let's dive into some code. On the left is a Java class that represents a student. On the right is the same class but in TypeScript. We know that a class enables the encapsulation of data and behavior, and it's really the same. We have fields, constructors, getters and setters, and of course, methods. Alright, now that we got some basics down, let's start programming. So for this small example, I'm going to create a function called foo, and I'm going to increment the value of a, whatever it is, and then return it. On line 6, I'll declare a variable called a, give it the value 4, and on line 8, I'll do a log statement, console.log, and call the function foo. Semicolons are optional, but I like putting them in just to be explicit. What do you think will happen here? Hopefully you've had some time to think about it, and obviously what will happen here is an error. We're obviously correct, but let's just run the code to see what happens. I'm going to run it by invoking node on the name of this file, which is test.javascript. Oh, we get back 7. That's not great. So this is a pretty common gotcha you'll come across. Declaring variables with the keyword var effectively makes them have global scope. They're also subject to what's called hoisting. This means that no matter where in the file you declare them, they'll effectively behave as though they're the first thing you defined. Alright, now that we know that using var is dangerous, let's write some code that doesn't use var. So I'm going to start off the same way by declaring a function called foo, and here I'm going to declare a variable a using let, which is safer than var. So we let a is equal to 3. Let's increment the value of a by 4, which should give us the value 7. And you know what? Let's try reassigning the value of a to a string, say Elisa. Okay, and let's return the value of a. And on line 8, I'll just do console.log and call foo. Alright. Why don't you take some time and think about what will happen here? So we know from Java that declaring a variable with one type and reassigning it to a value with a different type is an error. Let's see if the same thing happens here. So we get back Elisa. Looks like JavaScript doesn't really care if we reassign the value of the variable a, which has some type number, to a string. This is where TypeScript comes in. Okay, so now I'm going to rewrite the same function but in TypeScript. We start out pretty much the same way, function foo, but we're going to give the function a return type, and that's going to be of type number. So just as we did before, we declare a variable a, but this time we're going to give it a type annotation of number, and we give it the value 3. Let's try reassigning a to Elisa. So a is equal to Elisa, and it's already erroring out. There's a red squiggly line, so let's hover over it. All right, and it tells us type string is not assignable to type number. So we've already caught the issue that we pretty much didn't catch before. So let's try listening to our compiler, deleting line 3, and just, returning a to satisfy the compiler. So let's try running our file. So node test.ts, and oh, we get an error. But that's expected because Node can't run TypeScript files directly. The first thing we need to do is we need to compile our TypeScript code using TSC. And this gets us back a JavaScript file with the same name. So we can run that, node test.js. And we don't get anything here because I've forgotten to put console.log. So let's put that in right there. Console.log. If you think I'm making a lot of errors now, you should see me when I'm actually programming. All right, let's recompile our TypeScript code. Now we can run our JavaScript code, which has been generated by TypeScript. And here we get the value 3, just as we intended. Okay, so that's all pretty cool. But if you're a really lazy developer like I am, and believe me, I am lazy, you kind of don't want to spend any time annotating your functions or your variables with types. Because let's face it, it's 2021, a language should be smart enough to kind of do that by itself. So luckily, TypeScript has something called type inference, which lets the compiler kind of infer what the type of a variable is without you explicitly needing to tell it. So this TypeScript program is actually valid and identical to the previous TypeScript program that we annotated with types. All right, let's write some code that works with lists or arrays. So on line 2, I declare a variable called nums, which is an array containing numbers 1 through 4. On line 4, I've left the function stub where I have a to-do for you. Return an array where every element of the given array has been doubled. And on line 8, we have an easy console print to check our answer. Why don't you take a few minutes to try this by yourself? So pause the video and come back later. All right, so you've probably had time to try this on your own, so let's get started with the solution. So I'm going to start by declaring, so we're going to have to double every element of the array. So I'll start by declaring an accumulator where we're going to hold the doubled elements. We're going to call it doubled, and then create an empty list by just doing some square brackets like this. So we'll want to loop over the elements of the given array. So we're going to use a for loop for constant n in the array, because we have an array of numbers. We're going to add to doubled. We're going to push the value of n times 2, because we want to double it. And go to line 9, and then I'm going to basically write return doubled. That looks pretty good to me. So what I'm going to do now is I'm going to run our code like always and see what we get. Okay, so it says doubling 1, 2, 3, 4 resulted in 0, 2, 4, 6. So that's not quite the answer we wanted, but it looks right so far. Well, we've written the for loop. But the issue with this is there's a special gotcha in JavaScript where you have a for loop. Whenever you use the in keyword, you're basically iterating over the indices of the array. So here, when you're iterating for n const n in array, you're basically iterating over the values 0, 1, 2, 3. But we want to get the values of the array, not the indices. So what we do here is we change in to of. So let's see if that fixed the issue. We're going to run node again, node on starter.js. And it looks like we have the correct answer this time. Doubling 1, 2, 3, 4 resulted in 2, 4, 6, 8. Okay, so we have a working solution, but I want to show you another way to do this. And this is going to have to, make you think back to 110 a little bit. It's a pretty long time ago for most of us, but I'm sure we all have very happy memories from that time. So what I'm going to do is I'm going to draw your attention to the fact that our double elements function, all it's doing is it's taking an array and applying a function to every element of the array. In this case, the function is just taking an element and multiplying it by 2. If you remember from 110, there's a built-in function that lets us do that, and it's called map. So I'm going to return array.map, and given an element of the array, we're going to basically take it and multiply it by 2. Okay, this looks really short. I hope it works. So let's give it a shot. Just run node starter.js and okay, doubling 1, 2, 3, 4 resulted in 2, 4, 6, 8. So it looks like you really did learn something back in 110. All right, so we're really flying through some code here, so let's move on to objects. So on line 2, I declare a basic object variable, and it's an object. So you'll notice on line 3, we're inside the object, and it's just one key, some number, paired with a value of 1. On line 4, we have a key some string paired with the value of foo. Now, let's say we want to access the values of these objects. So let's try to get the number 1. So we're going to do console.log basic object, and we're going to do dot some number. This is probably familiar to you if you've done Java before. And another way we can do this is we can do basic object, and we can do an array access, or like an array notation access of some number. And this, if we run our code, should give us the same result. And yep, we get the values 1 and 1. All right, that's all really cool, but what happens if we want to access a property using a variable? So let's say we have a variable key is equal to some number. And then we're going to just do the same thing we did on line 7 and 8. We're going to do a console.log basic object dot key. Now this should, or we think it should give us back 1. So let's check out what happens. Okay, so it prints 1, 1, and undefined. This is tricky. What's happening here is that JavaScript just thinks that everything after the dot is an implied property of the object. So it's looking up the key in basic object. So it's literally doing something like basic object of key. That's not what we want. We want to access the value assigned to key. So what we can do instead is we can instead use the array access notation for an object, write key, and this gives us what we want, 1, 1, and 1. All right, so this is where the fun begins. On line 1, we have our basic object, and on line 6, we have our complex object. It's a little bit more tricky than what we've seen before. There's some nested objects contained within it, and we even have references to our basic object that we defined up top. On line 22, we have a function called countNumbers, and there's a to-do for us to complete. Given an object, which itself may contain other objects, we want our function to return the number of values that are of type number. On line 26, there's a print statement for us that'll print out how many numbers that we counted, basically. So why don't you pause the video and give this a shot. All right, so you've probably had some time to work through it, so let's go through this together. So what I'm gonna do, or the first thing I'm gonna do is I'm gonna declare an accumulator where we're gonna count the number of times that we've seen something of type number. So the first thing we do after that is we check if the type of the item is equal to an object. Then we have a little bit more work to do. We have to look inside the object for numbers. Well, if that's not the case, then let's do another check. Else, if the type of the item is already a number, then yay, that's really great. We can increment our counter and be done with it. And at the end of this entire process, we're just going to return the count. So far, so good. So let's go back to the true branch of if the type of item is equal to an object. Here, we're going to have to look into the object's values. So let's do a loop where we have a for loop, where we have values of the object's values. And here we know that val is an inner entry of the object. So since we have an inner entry, and it could be an object or a number, we somehow have to write a function that counts the amount of numbers within the value. But the thing is, we already have a function that does this. We're writing it right now. So here I'm going to trust the natural recursion and call count numbers on the values. But we're not done quite yet because we have to add the result of this function call to our count. We're going to have to basically update it. So we're going to do count plus equals count numbers. Okay, this looks good so far. So I'm going to get rid of our comments. And let's try running our code. So I know that there should be 7 values of type number. So let's give this a shot. Run node starter. And hey, complex object had 7 values of type number. So we're all good to go. All right, so that's about all the time we have. But before I let you go, you'll notice on line 22 that I've added a complexer object. And I'm very creative with my naming. So your task is now to update this count numbers function such that it supports, so implement support for the complexer object. And the main difficulty associated with this task is that now you can have null values, and as you can see on line 28, you can also have arrays. I can't wait to see your implementation on Piazza. Good luck.